Hey, all right, this is John Park, and welcome to John Park's Workshop. Hey, everybody, thanks for coming by. It is so great to have you here. I'm very happy to welcome everybody over in the chat, Discord chat and YouTube chat. Thanks for coming by, and it sounds like sound is good and the video is working. So, as many of you know, sound is one of my primary concerns here today, given my half hour of silence during my broadcast last week. But guess what? I have countermeasures in place. We are fully ready to deal with emergencies today. So the problem is I didn't have a good way of knowing when my audio dropped out, and usually the audio dropped out because of something I did, something dumb I did in the software I'm broadcasting with. But there wasn't a good way to capture messages from that software saying, hey, your audio is down. And it's not usually because my mic isn't working, so it's not like I could intercept some signal with a device, a sensor to listen. So thank you, Matamala. Yes, why didn't I wear this shirt last week? I saw it like right after I broadcast about the crank and slider, but luckily we're going to do something related today, so I thought, good shirt for the day. It's the Steam logo, but it's a cool crank and connecting rod. So check this out. I have a few people out there in the internet world with access to an application that is connected to Adafruit IO that will be used as an alert when something goes wrong during my broadcast. So any of those people, if you want to go and hit your button right now, just hit the red button, don't hit the green one, and we'll see if we get an alert to work. I'm going to check my dashboard. This is something I tried to share yesterday on Show and Tell. And let's see, I'm going to swing over to this video and hopefully not lose my audio when I do this. Let's see, where did that one go? Oh, there it goes. Do you see this alarm? Yeah. So that's what's going to happen when my audio goes out. From now on, if someone who's watching, who's among our moderators or people at Adafruit who have access to the application, we can ring this glorious device. So I'm going to pull the audio out of it right now. So it's just the video. And while that's going off, let me share the screen. Where did I put you, screen? I swear I added one. All right, well, this is nearly always guaranteed to make me lose my connection when I add one of these screens. So let's go over. Oh, here it is. Okay, so that's my Adafruit IO dashboard. If you're not familiar with Adafruit IO, it is a service that allows you to connect Internet of Things. So it allows, in this case, I have a Feather, which is the Huzzah 8266. I just saw someone wrote 32 in the chat and it blew up my brain. So I have the Feather Huzzah, and that is a Wi-Fi microcontroller. You can sort of see what I've got going on there. And I have a big honkin' power relay on it. It's slightly unnecessary relay. I mean, I need a relay. This one is huge and can handle AC at pretty decent amperage and voltage, but it's the one I had put together, so rather than one of the little smaller ones, that's what I'm using. Because this is a 12-volt tower, LED tower and alarm gizmo, if someone wants to hit it again, go ahead and hit again. And watch if someone want to hit the green button, actually, you will see, actually, I'll do it myself. We'll probably start battling over control here, but I'm going to hit this. Oh, someone just hit it as I was hitting that, so we have a little bit of clash of signals. Green means it should be in the clear, and then when someone hits the application, which looks like this, then come in, hit alert, and there you can see, and that's pretty fast. Most of the time I've had these really quick response times, which is super impressive because it's traveling from my machine or someone else's machine through the cloud to, not through the cloud, through the internet, to the Adafruit IO feed, and then I have an Arduino application running on that Feather that is connected over Wi-Fi to my machine and therefore the internet, and it can receive that toggle of that button. And this also ramps, graphs the instances of this being hit. So when I had just sent this to PT, Phil Terone, Mr. Lady Ada, the application yesterday, and then I stepped out for a little bit, and while I was out, he clicked it, and that was it right there. And I hope to add some logging stuff. So this is a fully secure, authenticated thing, and big, huge thank you to Adam Bachman, who wrote the little application here in glitch.me, that does the authentication necessary to talk to that Adafruit IO page. So hopefully that means that I won't have any more silent movie sections of the show, or if I do, they'll be intentional because I'm practicing miming. All right, that out of the way. Keep your eye on that thing. If you stop hearing me, you should hopefully see that thing flash, and then I'll go fix the problem. And next, I want to mention today's coupon code, which is garage door. You can't really read that with me in the way. Garage door. Let's put my workshop back there. We'll put that back there. There we go, 10% off in the Adafruit store if you use the coupon code garage door today. And you can load your cart up with all sorts of good stuff, except for gift certificates, subscriptions, and software. But anything else you put in your cart, you'll get 10% off, and that is good until midnight tonight. All right, so let's see. I'm going to look at my notes. What are we up to? And where'd my chat go? Oh, there's my chat. Hey, chat. So today, we've got a few things in store. We're going to do, let me get this out of the way. Hopefully you've copied that down. We're going to be working more on some cardboard robotics fundamentals. And we're also going to do a MakeCode Minute where we do some of the programming for the project that we'll be doing. And we'll be covering adhesives and joinery with cardboard, different ways of gluing and taping and bolting stuff together with fairly common, or in some cases purpose-built hardware or tools or adhesives for the job. None of the adhesives are purpose-built, I made that up. And we'll also talk about some stability and reinforcement with structures. And we're going to be building a little garage. That's why garage door was today's code, and Pushrod garage is the title I've got today. So we're going to be using another linkage mechanism that is useful for, in this case, opening a garage door. It's also similar to something you may have seen if you've done any RC plane building or assembling of the parts in RC planes. So we're going to talk about ways that we can actuate stuff with servos and the Circuit Playground Express. And what else? So why don't we move on to the product of the week. So the product of the week is our friend, the Circuit Playground Express. Super great board. I use them all the time. I used it in last week's project. I'll be using it this week, if I can find the one I just set aside. Here it is. By the way, if you don't know, when you order a Circuit Playground Express, you usually get it in this cool retail packaging, which is neat. I think this got put together because we sell in the stores at Micro Center. I'm not sure if there's other physical locations where you can get it, but Micro Center carries these. So Circuit Playground Express, it also comes with a cool sticker in here if you get this packaging, this silver Adafruit sticker. So Circuit Playground Express, there's the PID. So if you go to adafruit.com/product/3333, that'll get you there, or adafru.it, adafru.it/3333. And here's just a cheat sheet of some of the features that are on it. So it is an ATSAM-D21 M0 chip. Lost my mind for a second there. Very powerful chip, lots of memory, can do lots of stuff, can do USB. You've seen me do some projects where this thing is acted like a keyboard or a MIDI controller of USB, pretty cool. It has all of its connections broken out to alligator clips so that it's easy to work with and prototype with even if you don't have a breadboard. In fact, today we'll be just alligator clipping to it. And a lot of these pads have other functions, such as power on some, ground on some. We have capacitive touch sensing on some. We have a real audio out on one of them. The built-on stuff is bananas. So you can see here, this mentions we got the light sensor. There's a temperature sensor. There is a pair of buttons. There is a slide switch, the speaker, the microphone. What else am I forgetting? There's an onboard LED that just shows green when there's power. There's also an onboard LED that you can ping on pin 13, like a lot of traditional sort of Arduino microcontroller projects where you just want to blink an LED. We have a red LED on there for that, and we'll be actually using that today. So that's the product of the week. And now we're segueing. We're going to segue into a MakeCode Minute that uses this very thing. And so if you're not familiar with this, oh, someone is blinking my thing. Why? You shouldn't do that unless it's an emergency. My audio is still working, right? I'm going to check the chat. This will be my operational procedure here. If the red light goes blinking, I'm going to check the chat. No, it looks like we're good. All right, a false alarm. I'll plug in the audio again just because it's exciting and fun when we hear that alarm going off, unless it gets too bananas. But I trust the people that I've given access to the powerful red button. So MakeCode is one of the 3 primary ways that you can program the Circuit Playground Express, those being CircuitPython, which is a version of or a fork from MicroPython, which is very Python-like, as you might guess. And then we have Arduino, so you can use Arduino, compile your code, send it to the board. The Circuit Playground Express is run in real time on here. And then this third way, which is our good friend MakeCode. So MakeCode is a Blockly-based, so Blockly is the framework for the UI of connecting these blocks together, which can then be constructed to do different things for different systems. So this, in this case, was created by Microsoft. It's an open source project. It's simply awesome. I love MakeCode, and it is very similar to Scratch. If you're a teacher or a student or someone who's played around with Scratch, it'll be, I think, very quickly familiar how you work with it. Oh yes, thank you, Matambale and Dave Smith. You can hear me. It is not, the audio has not gone down. Dave, did you just join us? Because guess what? You may think you're just being funny, and you are, but I have this thing now, and this thing is going to alert me when my audio drops out because I have some trusted people in the chat who are watching and listening and have a red button, an internet button that I gave them that will alert me when the audio goes down. So hopefully no more silent workshop. So back to MakeCode. So what I've got here, this is the sort of final program that I've created for this garage door project. But what I'd like to do is sort of reconstruct some of it in steps. And this is kind of a nice teaching method you can use with MakeCode. You can create duplicates of blocks that you have or create from scratch from this little palette. Things that you already have out here and sort of talk about and look at them or take screenshots as you go. So let's see. What I want to start with is inputs. So one thing we can do is take an input, and I'm going to just eject the contents of this one so that this one will take precedence. Oh, did I lose audio? No. People can't control themselves. They think it's fun to press the button. All right. There will be testing throughout this show today, I am sure. So, or it's lag. I don't know if there's delayed sends coming. But so here is an input that I have that will take either button press A or B, buttons A and B at the same time, or any of the pins if they have been sort of externally connected to a wire and grounded can be used. So what we're going to use here is button A, and you can either click it, hold a long click, only on the down or only on the up. So we're just going to do on a full click. What we'll do is move a servo, so similar to something we did last week. So in the Advanced tab here, I'm going to pull from Pins, there's this section servo, and what I'll do is write to pin A2 is what I'm going to plug the servo into. So if we take a look at our Circuit Playground Express, and I've got some alligator clip wires over here. This is a fairly common way to do it is if we take this signal one, yellow, that's going to go to the signal line on the servo and connect it to either A1 or A2, which have PWM outputs, and then these can go to Vout and ground. Then we can control a servo by sending a command to that pin. So this one will send this servo write. I wish that one weren't so transparent. Can I guess I'll just delete that one. Boom. Servo write pin and then pick an angle. So if we go, you can go from 0 to 180, and once we get to building the real garage door opener, we'll have to test sort of where we want what direction it's going when it's opening and closing, what the limits are on that. But let's say we want it to go to 90 degrees when we press open, and I can duplicate this and use a B button and change, let me get rid of this one over here as well, so that you can see this one. Change the angle when we press the B button, let's say back to 0. So that could be open 90 degrees, close 90 degrees by pressing A or B buttons. So if you look now at the extra stuff that I've put in here, I won't rebuild these from scratch, but I'm going to talk about what I'm doing in here, just the logic of them. So first of all, I like to have a little bit of a clear indication that I've done something when I press a button. And so, oh, by the way, Adafruit just chimed in on the YouTube chat and said, nice work on the clear MakeCode. So Filterone, PT, Mr. or Lady Ada, showed me this very cool trick that I think someone at Microsoft might have let him in on, that uses a sort of a URL hack in the browser that changes, it's a JavaScript hack that changes the background color. So we're changing the background color to bright, bright green, and then I'm chroma keying that out inside of Wirecast, which is our broadcasting software. So this is a super cool trick, and it lets you hide behind blocks and peek out among them. So thanks for that trick. That's a very cool trick. So since I want to have an indication that I've pressed a button, I have digital write pin LED. That's that pin 13 LED that's just up here in the corner, this little D13 LED. That will go red when I click the button by setting this to high. I also want to play a sound, so I'm playing a high note when it goes up and a lower note when it goes down for half a beat. I turn that light off, I turn that light off. So same thing's happening in these two. And finally, I open my servo or I close my servo. Now you'll see here I'm using variables to make my life easier since I'm using different angles, these two different angles in a few places, but I was tuning them a bunch. Over here in my startup, this is sort of the initialization of the whole program, one of the things that I do is create a couple of variables and set them for closed 170 degrees is what I settled on, and open 70 degrees. So now I'm just reusing those variables. I could have this button close it instead of open it, and that's as easy as just choosing this drop down of the different variables that I have. So those are how the buttons work. Now, another cool feature is having an alternate way for this to work. Let me move this off my face. There we go. And this is an input that's available again from our input category here. It says on light dark. So you can have on light dark or on light bright, and then you get to specify. I'm specifying here in my startup the threshold. So I have it has to get pretty darn bright. 240 out of a possible 256 is the threshold where I want the Circuit Playground Express to know that some bright light is being pointed at the light sensor. So what I'm imagining for my toy garage is that this is a headlights on a car. So maybe we have a flashlight taped to a toy car, or you've got a model car with some LEDs in the headlights. So when the light goes bright, what I'm going to do is same sort of thing we saw before. I'll ping my little red LED. I'm actually going to turn on all the pixels briefly to a color, sort of a light blue. I'm going to play a sound. This is similar to playing a note, but it's a pre-programmed little melody. Then I'll hit the open angle on my servo. I'm going to show a little animation for 5 seconds to know that the door is open and we're kind of waiting for you to drive in. and then it's going to set all pixels to red to warn you, hey, the door's about to close. We'll play the jump down song, which you'll hear in a second, and then we close that back down. And then I also wait a second just to avoid accidentally triggering it again if the flashlight you have is still pointed at it. And then I set all the pixels to black. Finally, I turn off that little red LED, and that's the full cycle. So this will be part of a Learn Guide tutorial that I'll be putting out tomorrow. I just have to write it, finish it, do everything on it, but we'll have that out tomorrow, I promise. Maybe late tomorrow. And you'll be able to use this program on your own Circuit Playground Express with a servo motor. And that's all you'll need is some wires. I like these alligator clip wires I showed you that have the male header pins and a servo motor. Okay, so that's how the MakeCode works. And if anyone has questions about that, please pipe up in the chat. We're watching the Discord chat and the YouTube chat. But if that satisfies that, what we're going to do is hold that in our brains for a second, and now we're going to step over to the workbench for some tips and tricks. So let's head over to, oh good, my main camera just broke. Hold on, I'll give you a down shooter for a second while I... This is my newest and most expensive camera, and it's the one that likes to turn itself off when it gets just mildly warm. I really need to put a heat sink on the back of it. All right, you can do it, little camera. Luckily, I've got a couple other cameras, so we can find a way. I can talk to you up above the workbench if necessary. All right, we'll see how long that one lasts, and let's go to the down shooter view there. So, what I'd like to talk about with our cardboard techniques today is joining and adhering cardboard. So last week we looked a bit at different cutting techniques. All right, I love how prominent my... Oh, I forgot. I had a little robot friend on my light here. So there's an Adabot who will be part of saving me from silence. So let's see. We looked at cutting cardboard. Let's now look at joining cardboard. So I have a few adhesives to talk about. So we've got white glue. We have, should I go in order? Sure. So we've got white glue. No, that's not in order. We've got super glue or CA glue. What's it? Cyanoacrylic? Crinoacrylic? I forget. CA glue. Super glue, crazy glue type of glue. White glue, also called PVA. We have contact cement. And did I do another glue? I think that's it for glue. Oh, and hot glue. So I have a couple of hot glue guns here. I've got my shop one, which is a high temperature hot glue gun. And then I have your typical little dollar store kind of craft glue gun. A note about these, they always just tip over, so I had welded some tube steel to a little piece of plate and shoved the gun in there so at least it has a heavier base and doesn't tip over all the time. This one has a nice convenient stand. So these are, let me switch to overhead for a second on the main cam. Oh, I gotta remind my program that I'm talking to it. All right, so let's go to that one and that one. So here's a little sample board I made of some different, in this case, the glues that I just mentioned. So here's our CA glue, and it just didn't work, right? You saw that just fell. I had just blobbed a little CA glue onto the cardboard. Oh, let me keep that there. I don't have this on autofocus. And it just fell right off. Here is a straw. So this was cardboard to cardboard. No good. Here's a straw. It just popped right off. So I don't know if there's maybe better luck you can have with a gel type of glue. This is a liquid type of CA glue. And I've heard of people using it in cardboard construction, but it didn't work at all for me, not even one little bit. So I'm going to take that off of my list unless I get some feedback from people and they tell me some trick that I don't know that'll make all that work better. Let's see. Actually, there aren't that many applications in life where I reach for CA glue. It just is often disappointing to me. So, sorry, I'm just going to pull up the YouTube chat over here because I don't have that one on. Oh, hey, there's Phil. We're listening to last night's Ask an Engineer. So, top chat and live chat. All right, so anyone? Cyanoacrylate, thank you. So cyanoacrylate is the CA glue. It just did not work for me in cardboard. White glue, here's white glue, and that, actually that's a bad, I just cheated there because that was tape. I didn't realize that was some masking or some packing tape there, so it did not stick to that very well. Let's actually just re-glue that and we'll come back and look at that. And we'll see how our straw did. Because I think white glue does work pretty well for cardboard to cardboard. It just takes time to dry. So what I think we'll find is that that does a really perfectly beautiful job of connecting cardboard to cardboard, face to face, or even edge to edge, as we're going to talk about in a little bit. But it did not work against some packing tape. So here's a little straw, and it just popped off. So the straw is just not absorbent of the glue enough, and I think that may be one of the key factors for getting that to work is, sorry, I'm going to try to focus that a little better, is something that's just not going to happen. So PVA or white glue, I think you're good cardboard to cardboard, but not so much with plastic to cardboard, which is something you may find yourself doing. I didn't test these, but I'm pretty sure that white glue on wood glue sticks will work, or wood paint stirrer sticks or craft sticks will work perfectly fine. We can set one testing right here, how about? So we'll just rub a little of that in. Yeah, I got some masking tape on the back side of that, so this is, hopefully that'll work out well for us. So contact cement. Contact cement, I took this contact cement here, and the way you use it is you spread a moderate layer, moderate to thin, doesn't have to be super gloppy, on both surfaces that you want to join, and you let this dry for usually 5 to 15 minutes on both pieces. So we can do one right here. In fact, let's glue to the board. So this stuff smells pretty volatile, so I don't know that you'll want to use it in a school setting, but I'm going to put some there, and here's a fresh piece of cardboard. Oh, I'm going to put some there, and we're just going to let those dry for a little bit, and then we will bring them together. So my example one I showed here, these have been brought together and they still have a little bit of stretch. Oh, I can see that my main camera just went out. All right, let me switch away from that one for this time being. So let's do something weird here in the corner. Let's see if this one will focus up like that. Hey, I'm upside down. Swap that. I don't know if that can focus very far. It sort of did. Hey, all right, so I'm kind of in the corner there. So the contact cement, you let it dry. It kind of bonds to the surface, each surface, and then it really loves to bond to itself when you bring the two pieces together. This has been probably 2.5 hours that this has been sitting here like this, and you can see it's still a little bit pliable. I can still kind of peel it apart, but if I leave that overnight, it probably is going to be fairly bulletproof. And let's see if I can, maybe I can focus it on this one. I'll get my face out of there. And not quite. No. Hopefully you can see there. There's a little bit of like stretch of the contact cement as it tries to pull apart. So I would say there may be cases where you want to use the contact cement. It does work well, but it takes some time to initially set and then more time for it to dry. I used it recently because I had to recork the joints on a clarinet, an old clarinet I had that my daughter wanted to use. Oh, thank you, Dave Smith, in the chat for mentioning the camera died. How come no one pressed the red alert button? I guess I caught it pretty quickly, but red alert button is okay for cameras too. So then we have hot glue, and so here are two pieces that I joined with hot glue. I just tore the cardboard trying to peel them apart. The glue is not going anywhere, so it's pretty bulletproof. Here's a straw, and look at this. This is really on here good. So as you may be able to guess from my enthusiasm here, hot glue is probably the best answer for your overall, if you have just one adhesive you're going to use for cardboard stuff, because it'll stick plastic to plastic, plastic to wood, wood to cardboard, cardboard to cardboard, and so on. And a low temp, let's see, so that was the high temp one. Here's a low temp one, same thing. So you can, yeah, I've torn the cardboard, the glue does not lift off at all. So this is safer in a classroom environment or a maker camp or that kind of thing. So if you have younger kids that you're worried about burning themselves, or adults worried about burning themselves because the high temp hot glue guns are really hot, then you may want to look at these because they work really well for our cardboard joinery. Someone asked about rubber cement. Dastel's asked, and I have some and I didn't try it. That's a good point. And the other thing I didn't really try was a glue stick, which I think if you're using like a non-shiny cardboard, you'll be able to do cardboard to cardboard with a glue stick fairly well. And certainly if you're trying to put paper as a decoration or as some sort of a labeling system, then a glue stick will work really well, as probably would with spray adhesive, but you usually need a spray booth or to go outside with that. So here's our rubber cement. I actually don't know, I don't think you use rubber cement like contact cement. I think you just put one blob of it down and put everything together. So we'll just do a little rubber cement there. And we'll cut off a little fresh slice of cardboard. And we'll set that on our rubber cement. Okay, so that's for adhesive. So I would say white glue and hot glue are probably the two best bets for the typical cardboard making projects, classroom types of projects. Let me move that away, and then we'll talk about tape a little bit. So here's packing tape. This is your, let me zoom this camera out a little bit. How's the focus? There we go. So this is your typical box tape for shipping. I've just taken a little slice of it off and taped together a couple pieces of cardboard. And you can see it peels off pretty easily. It's good for closing up a box, but it may or may not be the right choice for your cardboard projects. Also, it itself is super slick, so unless you have a reason why you want your surface slick, it becomes harder for other things to adhere to that. Except tape to tape works pretty well, so you could end up making little tape loops if you had to put something on that you'd like to be able to remove if you're doing like eyeballs on something. I don't have any googly eyes. I really should have googly eyes. What can I, okay, we'll take this, one of these little servo horns. So if you're doing temporary tape-to-tape stuff, that'll work pretty well. But I don't find that packing tape is super helpful. It's also pretty stiff, so when you do try to loop it, it wants to pop back out. Masking tape, real masking tape, not the blue tape that you use for painting or for your 3D printer bed, but real masking tape is pretty sticky stuff. And I find that it works very well, especially for, again, sort of temporary joining of stuff that you then want to cut holes in a certain position or join things. But you can see here, if let's say I'm trying to hold this at this angle here, masking tape works really well. And that surface is fairly matte. You can still write on it even with a pencil. I know that there's other more colorful, like washi tape. It's not as sticky as this regular masking tape, but it's another really good choice for tapes. I think, I haven't tried it, but I think, is there tape that came with the Nintendo Labo? There's they suggest doing tapes for your decorations, and I don't know if they provided any in there, but I'm guessing that's something like washi tape, which is a paper tape. Another tape I tried, I really like this stuff just in general. It's paper packing tape instead of plastic. It does have a waxy side. I don't know if they make matte stuff. I feel like they did when I was a kid. My parents used, this is sort of a shiny paper tape that blends nicely into the look of cardboard. It has a real classic, to me at least, kind of cardboard look and feel, but that's a shinier one, so it may, you know, I don't think I can write on there with a pencil. So again, it may be an asset for what you're doing, or it may not be. And then there's double-sided tape. Well, Scotch tape, I'm just going to say it's not that great to work with. It'll do, but you're better off with masking tape. It just doesn't stick that well. And then we have double-sided tape. So this is a pretty good Scotch double-sided tape. They call it permanent. I don't know if they make an impermanent one, but so there's a double-sided tape. Hi, Yannick. You did not just miss the first 5 hours of the show. But Yannick, guess what? I have an alert thing. You can't see it right now because my main camera went dead. Let's move it here. I have this alert stalk, and that will blink red when my audio goes down because there's some trusted friends out there helping me monitor things. So this double stick tape works very well for doing, again, face-to-face cardboard stuff. So if I just set some down here and then set this piece of cardboard on it. One issue you find, though, a couple issues. You got to cut it pretty precisely, otherwise you end up with excess that wants to pick up fur and hair or help lift off the rest of it. And two, you kind of need to compress your cardboard. You have to push pretty hard to get this to stick well. I found because the surface is kind of bumpy and porous, there's only minimal surface contact between the double stick tape, especially this thin stuff. A foam tape would probably be better because it compresses a bit and therefore its adhesive gets kind of into the pores of things. So let me cut off a piece of this. What I find with the regular thin Scotch tape or transparent tape style double stick tape is that it is going to force you to squish your cardboard, which if you're using corrugated cardboard you may not want to do. So here is some double stick foam tape, and if we set that there, cut off a nice little chunk. Again, you want to get the size accurate, but here you'll see just pushing that down a little bit, it's stuck pretty nicely. I only just gave it a little bit of a and it gets up in there because it's able to conform to the surface a little bit better than the plastic where you've really got to push hard. So that's, again, probably a good face-to-face or object-to-cardboard type of tape to use. I didn't include gaffer's tape or duct tape. They'd both work really well, but probably not as classroom-friendly to have duct tape. Gaff tape is great, though. Okay, and then I also want to talk about some sort of two other things with cardboard joinery. So we have cardboard to cardboard joints, and we also have mechanical fastening. So let's do cardboard to cardboard joints. I'm going to zoom this camera in as close as it'll go for this and try to focus. Yeah, I had to switch to manual focus on this overhead because it really likes to freak out because of that pattern of this cutting mat. So here's a cool technique I learned. I'm going to put some links on a guide that I'm writing about general cardboard techniques. I'm going to put some links to the guy. His name is Jude, and I'm forgetting his last name now, so if anyone in the chat remembers who I'm talking about, I think Phil saw his... Ooh, did my video stall for a second? That's not good. Real cardboard prototyping master, and I'm forgetting his name now, so many apologies, but I will link to, I saw a very nice, sort of kind of like a lap joint technique for cardboard. So let's get off a nice fresh slice of cardboard to work with. And I'll show you this really nice edge to edge technique at a 90-degree angle. You could probably do other angles, but cutting sort of chamfer into cardboard is going to be pretty tricky. And I don't know if you could sand it into that angle without really mangling things. So let's get these sort of straight. This will matter, actually. Use my cutting. Oh, let me move this so you can see it in the camera. Oh, you know, I'm going to hide that tools and techniques thing. You know that we're doing tools and techniques by now in this segment of the show. So I will boop that off of there. I'm also going to try to give my poor ailing camera over here, my main cam, another attempt at waking up. And it is woken up. The lens is alive and extended. All right. I'll tempt fate and switch to that one. Yeah, all right, that works. Let's go there and there. If that one goes off again, tell me. I can put this one down now. So let's get some straight cuts in here. I'm kind of now wishing I had two fabric cutters because I really like having this skip cut perforation one on here, but I don't love switching it out. It takes a little time for the more circular pizza wheel fabric cutter, but it works really well. So let's say that we want to join a couple of pieces at. You can certainly put hot glue on an edge and go like this, and you'll get a very nice join. If you don't want to see that corrugation, so this is just more of a presentation thing, but I thought it was a really cool trick, what you can do is cut away the top face and the single wall of fluting, leaving one face at the width of your material thickness, like so. So I'm measuring with this. Looks good. And is my audio still on? Yeah. I'm so paranoid now. Now I'm going to go in and cut gently. I'm going to score a few times so I can see I'm bumping through some corrugation. That's good. And now I'm not really feeling the corrugation, so that means I'm getting towards that first face. I'll move this for you. So what I can do now is peel away. You can see I'm getting a layer of fluting, and I'm getting that top face, but I'm leaving the bottom face on there. And I'm going to switch over actually to this close-up camera, even closer upper camera for a moment so that you can see a little better how this is put together. And I'm going to rotate that again. Okay, and I will turn on this guy's light. Or so I claim. Yeah. Okay, so I've got to now square it up. I can't keep this thing. Once you've got a grid, it drives you crazy if you don't square everything up. Ah, okay. So here you can see I've made this sort of like a lap joint. Let me know if there's a better name for that, but it reminds me of a lap joint. And we're working by cutting away one face and the flute wall, but leaving another face. And this, if I've measured carefully, will be a pretty good fit for now setting in a really nice corner. I could trim away a little bit of that. I'm going to tempt fate and grab a small ruler and trim away just a little so that it's even better. Like so. Oh, what did I lose? Someone's beeping me. You tell me, chat. Cutting slim slots seems to take the longest of cuts. Alert, alert song. All right, I don't know who did it. I'm going to set up authentication. I don't want to cut my fingers off. Let's see, this is a better way to do this. If this knife is sharp enough. You do need to change these out quite frequently. Oh, I don't think I'm going to do that. Okay, you know what? Let's pretend I got that perfect because I don't want to spend the time right now. So what I'll do is I'm going to use the low temperature hot glue gun. because why not? And I'm just going to get a nice bit of hot glue there along this joint. And now I can set this in like so. And you can see, other than my depth being off, so I have a little bit of a fuzzy, let me refocus this for you. There's nice and sharp. Look at that, you get a really nice sharp 90-degree angle there. Beautiful. So a little bit of, I might be able to round that over, maybe put some glue in or shave that off with a very sharp knife or scalpel later. I'll let it dry now. So that's a really nice way to do this kind of a right angle joint, and without leaving a cardboard flute visible. The other thing I want to show you is that sometimes this is going to be perfect for your needs, especially if you have connected all walls, 4 walls or a triangle or something. But sometimes this will be a little bit weak. You can see, look how quickly the hot glue cools. It's so great. I used to be so anti-hot glue, and I've totally come around. So here's an example of making a little brace, a little corner brace. And you can, I don't want to take the time to do it because we're going to run out of time, but you can imagine all I did was just cut out a little triangle, made sure that I had a 90-degree in there, and glue that in. And you could make a stack, or you could, or this thing could be a bracket for something else, a nice, and that'll give it a lot of strength. So let's see, the other side of the coin for fastening, besides these adhesives, is mechanical fastening. And so I have a few examples here. Let's put this one in. Are you that one? Yeah, you're that one. And I'll get this to focus. So I have 3 types of mechanical fastening going on right here, and there are plenty more, I'm sure, that you could think of, but these were 3 that I had. Couple, well, I have one on hand, one I got at a store, at an office supply store, and one I not special order, but I got from Adafruit, and it's a sort of specialty thing. You may have seen me use these before. So this is called a Make-Do screw, S-C-R-U. And so there's a kind of basic package of them, and it comes with 2 lengths of these little purpose-built cardboard screws, as well as a couple of tools that are helpful. One is this poking tool that pokes the right size. So let's make up a scenario here where we want to connect, let's say, to the back side of this, since it's already dimensional. So I'll cut off a slice of this. So if I want to connect this as a tab or whatever, for whatever reason, onto here, what we'll do is poke. You could start a hole with something else that's sharper. This is safe, meant, you know, for kids, I think is the idea behind it. But I think it's great for me. But you can see the cardboard wants to deform a little bit with it if you can't get your hand up underneath and you want to make sure you don't poke your finger. It's not that sharp. But so now I've got these holes made because these have a blunt end, so they're not self-tapping or they're not pointy enough to go in, is what I'm trying to say. And you can start them with your fingers like that. You could probably screw them all the way in with your fingers, but it comes with this nice little hex driver. And it's got sort of big enough threads at the right heights to really get in there and hold things nicely. So those are super cool. And they also have an add-on pack, which is just more of the screws at a better price because it doesn't include more tools. I think that's, I haven't done the math, but I assume that's why we have that. So those are the screws. They're very cool, and I believe that, correct me if you're wrong, but I believe that the Ruiz brothers have done a remix of those as a 3D model. So if you go to, if they've put them up, if you go to Thingiverse, to the Adafruit account, they'll be up there at some point if they're not up there already. And so they're you could 3D print them. They're a little lighter than these. I think they tuned their settings to make them lighter. And I think they also may have given more of a unthreaded portion of the shaft so that you could do pivots. These ones don't pivot so well. In one direction, they're kind of they're loosening, and the other they're tightening. It's not terrible, but I think you could get a better pivot using the special built ones that the Ruiz brothers did. Let's see, the other one that I went out and bought was, you saw me use these last week, are these little brass paper fasteners. So let's give the big view over to that. So these come in a couple lengths. I got the sort of standard one. There's also shorter ones. But these seem good for going through a couple of holes and spreading until they have connected things. So I'll just put a quick slit in. So the nice thing is you can get away with just poking your X-Acto in, and then these will find their way through. Here's a little companion piece for him there. And you could kind of angle things. It's better to use a couple of them if you're trying to hold a particular angle, because you can see it'll still turn even though I just put a slit in, because the cardboard doesn't mind accommodating and tearing. And then you just flatten this out on the other side and you have a nice joint. And then one that I came up with that I thought was pretty cool for certain uses is to essentially make a rivet out of two zip ties. And so I'll do it here on this open end. You can see everything is now becoming part of one construction. So again, you can make a very small little slit and feed the zip tie through one side, and it makes a kind of small, let me zoom out a little bit. I'm going to go to this camera. That one might be a little easier. Where are you, little camera? There we go. And zooming, focusing, good. So you can see I've just popped a zip tie through this side, and if I'm going to join it to something, so let's take our little 90-degree wall that we made earlier. For whatever reason, I want to join these. So I will slide this through like so, and now put another zip tie on it. And since zip ties can connect to zip ties, oh, I got it the wrong way. We get a nice tight little rivet, and then you can snip these off with scissors if you want. You don't have to. And now I have a little connection point made with zip ties, which again seems to rotate fairly freely because the cardboard will loosen up enough to deal with that. You get much bigger zip ties, of course, and do different types of joints. I can't, oh, here's a case where I took, lift this up and out a little bit. So many cameras. Here's where I just wanted to join two ends together, so at any kind of a corner you could, essentially like stitching with thread, you could go in and put a couple of zip ties, and then you get a fairly neat little, fairly inexpensive and easy to make connection. So I think that's a good moment to move on to our project of the week. And I'm running a little long here, so we'll see if we can take care of this fairly quickly. And there's going to be a tutorial coming out soon on this. So the project build is going to be a Pushrod garage door opener. And so I made a little demonstration model. You might have seen this on social media yesterday. So this is a little model I made of our pushrod mechanism. And so what this is on this end represents our servo motor that's going to be able to rotate. And so I've put a crank, little piece of stick on there. As that rotates, and we could go, 180 or 90 degrees, we'll probably end up just going 90 degrees. As that rotates, there's a connecting rod here with two free pivots that then is pushing the connecting horn that's connected solidly, so there's no pivot here between these two pieces, to our object that we want to move, or our control surface. So if this were a model airplane, the orientation would be different, but it's the same principle, where we have a linkage that's being rotated by a servo arm. So this is our servo arm, offset from the axis of the motor, which pushes in a nearly straight line. The optimal geometry on these for an airplane is same height, same length. And then you get 90 degrees equals 90 degrees. But we're actually at the angles where we're a little higher, a little further away from this pivot, a little closer to that one, we get more like 60 degrees turns into 90 degrees here, which works out fine. So that's the mechanism that we're going to make. And so let's step over here to the shop, and I'm going to show you with some pretty basic supplies how you can get this going. Let's swap the camera out again. Let's go to, oh, let me turn off that thing. Sorry about that. I can't control all things from my cigar box switcher. So I'm going to do it right here. Let's see. Hey, down shooter. Oh boy, you're not, I wonder what you're in focus with. All right, so we'll zoom out and get that in focus. It seems to be in pretty good focus, and I'll go there. Last thing I'm going to do, sorry if you'll bear with me, I'm going to swap. I have a monitor here that I can switch a different HDMI into so that I can see a little clearer what that camera is doing from a focus standpoint. Don't you like how my show is 10% just about producing the show itself? There we go. Yeah, ooh, that's not in focus at all. Let's see. Okay, that's pretty good. So here's the idea. I'm going to do kind of a flat 2D version of this at first. So if, let's say, this is going to be our garage wall and the door. So the old-fashioned garages had a single piece door that just had a hinge running through it, a little bit offset, and giant springs to assist you in essentially rotating it up on a axis that was, or a pivot that was a bit higher than center. So if we, let me do this. If we cut out a little door here, I'm going to mark this before I cut it. I'd like these to be square, so I'm going to take a little bit of care with it. Again, these cutting mats are pretty helpful if you have at least some square edges on the material when you start. Let's do there. And there. I like to look every once in a while, make sure it's not just a picture of the top of my head as I try to explain these things from the overhead. And like so. That's largely straight. So this will be our door and the cutout in our wall all at the same time. I've seen there's a really good tutorial on doing a very simple version of what we're doing here. Oh, what have we lost? Why is that beeping? Sound and video are okay. All right. When was that? 1:49. Someone tell me if there's something wrong. You're definitely getting my attention with that thing, though. I think people are just doing it for fun, which I'm okay with. It gives us something to talk about. It also totally distracted me, so what was I saying before that? Who knows? Okay, so I was going to say there's a tutorial from Hummingbird Electronics using, they have a lot of great tutorials for cardboard box robotics stuff. And one of them they use just the bottom of a box lid as the hinge for doing a push rod. And definitely check that out. It's straightforward and well done. What we're going to do is just slightly more elaborate. And that is, I'm going to take my door here and I'm going to take a wooden stick. And that is going to become my hinge. And I'm going to use a straw as the pivot. Where have I put all my drinking straws? So just a regular drinking straw. And this is a dowel. You could use like a bamboo skewer that you probably have in your kitchen. These are 1/8-inch dowels that I got at a hobby shop. what do they call themselves? Dowels, 15 pieces. 3/16 of an inch by 12 inches. So I cut this one down a little bit already. So what I'll do is I'm going to just make this straw the same length, or roughly the same length as the door's width. I will try to get everything straight. So this is probably close enough like that. You could tack things down if you want it to be a little more secure. And then I'm just going to go in again with hot glue. One thing I've noticed is that the low temp hot glue gun is less likely to melt the drinking straw than my high temp one. And now I'm just rolling the straw up there and trying to keep things straight. False alarm again. That's all right. I don't mind. Was it you guys? It's so tempting. I would be very tempted. And now, in this case, I don't have any walls because I cut this away. But we can fold up a wall on this side here to show you how this works in reality. So let's. I still got to score that. Sometimes, even though that's the direction of the flutes, it sometimes doesn't really want to bend. Hello, tester. So I don't know if that's the system or if that's my people. I don't mind if it is my people, but I want to fix the system if it's giving false positives. I don't think I have multiple ways for that thing to trigger that I'm unaware of. And so all I'm doing is making a little hole to thread this stick into, and you could put it in just part way or force it all the way through, build up some material there. So imagine that I have one on this side as well, and now I cut this pretty tight, so it's a very snug fit, so we would probably want to shave off a little bit so that the cardboard doesn't have such a perfect fit that it has to make. But you can see here, this is how our door is going to open with a push rod. Let me zoom in, pushing against it. Okay. Now, fast forward a moment in the interest of time, and this is my completed garage. I've got the electronics there too. And you can see what I've done is I have a servo motor, and this isn't powered, so I should be able to just twist it. So I have a servo motor, and I'm gonna give you some focus there. I have a paper clip acting as my push rod, which only requires me to rotate, about a little less than 90 degrees, or maybe just 90 degrees, and it drives that door open. I can move this over this way, with the exact same principle as the popsicle stick demo that I made. Okay. Now, I said that I programmed this already, so that MakeCode that we looked at the top of the show during MakeCode Minute, I've loaded that code onto this Circuit Playground Express. So if I give it power, we can test the two ways of opening and closing this. So, okay, so first thing it does is beep. And there you can see it's just opened itself. Move this out of the way a little bit. Closed itself, and I think I've got to be vertical. So let me point this at the main camera. That's not going to shut the whole way. There we go. So we'll try that again. Open, close, open, close. So that's using the buttons, and now let me switch this camera again. Remember I had set the light meter, or the light sensor mode on this. And that's active as well, so I can manually activate that using those buttons, or if I grab a flashlight, which I have in my pocket here, so I'm going to, let's see, I've got this little flashlight here. Now, if I point this at, oh, get that back in Camera view. And it closes. So I'm fighting gravity here with the way it's oriented, so pretend that closes all the way. So again, if I give it the light, I said if I give it the light, what have I broken? Is it working still? All right, I don't know what I did. Let's reset it. Oh, yeah, there's a chance that I'm browning it out because of the power draw of that motor on the Circuit Playground Express. Oh, you know what? Maybe this is old code. Let's try that new one. Okay, so this is the one that I showed you at the beginning of the show. That's the one that I just programmed. So let's see if I swap my... So that's the alligator clip going to the signal line. That's to ground. And this is to voltage out, which should be 5 volts, because that's what we're getting from USB. But in case that doesn't work, I have a battery pack prepared with about 5 volts. We could try that too. All right, wake up. Let's see, if I switch, you know, I'm going to give you the real demo by switching cameras to this one. Sorry, we're running late, but not as late as last week, right? I'm going to go to this little guy here. All right, we'll keep him small for a second. I'm going to turn off his light. And go like so and like so. All right, so this is Matchbox car view. I forgot to go and get some Matchbox cars to use in this one, sorry. There we go. I'll get this out of the way. Let's see if we can focus. I can't see this one that well, so yell at me if it seems terrible. That looks focused from what I can tell. Okay, so let's just place this here. Get my flashlight. Oh, am I not connected? A3. That won't do anything. Did that get overzealous? So what you're seeing here is the trickiest thing with all this stuff is getting your linkage length correct. And for some reason, something wiggled here, and so it's seeming like it needs a little bend. That's a little better. Let's try this again. All right, so let's see if this works the second time. Does it? No, something's going on with that sensor. I don't know what's up there. Okay, I got some work to do to figure that out. Button works. Light sensor seems to work one time, and then it stops paying attention. If anyone knows anything about a bug with, let me make this the big view. If anyone knows anything about an issue with the light sensor on Circuit Playground Express or MakeCode and Circuit Playground Express, let me know, because I don't understand. That will work once beautifully. Yay! A little garage, but then it doesn't work the second time for some reason, because I just had it waiting a second. I don't know. We'll see. If there's something in my code that I'm doing silly, I don't know if I have to reset the light sensor or something. I've never had to do that before. Anyway, so that is the project. That is our project of the week with Pushrod Garage. Light Cubes ask, can someone elaborate what a Pushrod Garage is? So I kind of made up that name, but this is a little garage, and the pushrod is the type of mechanism that you see in there. I can run that manually while we watch it. And so when that, oh, my hand's in the way. So when that servo moves forward, it pushes on that rod, which in turn pushes the door open or pulls it when it goes in the other direction. Last thing, I forgot to show you this is just a paperclip pushrod, and it's fairly easy to make. Let's see if I can flip that. Does that seem at all right? This camera seems... Yes, okay. The way you can make that is take a paperclip like that, and what you're connecting to is some kind of a servo arm or servo horn. it out just a little bit. Sorry, it's a lot of camera gymnastics today. You can straighten this out. You can do this all by hand, or you can make a sort of neater one with pliers. So I'll straighten this out pretty much all the way. One end I've got a bend in, and that's what connects to the little mounting arm on the door, or you could even just tape it to the door or glue it to the door with some cardboard. And then on this end, there's a pretty common arrangement that you'll see again among RC airplane, or I don't know if car people probably don't use this, but for airplanes they do, which is you take some pliers and you put a Z shape into this. Do it here. I've got, these are weird pliers. You don't need weird pliers. Let me get some regular pliers. So an arrangement like one bend here and then another bend here. And you can hook the servo over that, like so. And so that gives you a pretty nice connection that pushes in a straight line. I mean, as straight as you can get this paperclip to be. And it doesn't slip out very easily. And it has a little bit of compliance. It can deal with funny angles, which you usually end up with when you're making these cardboard things. So, let's see. At 2:06, the Adafruit account said on Discord, I do not think any of us would do that, so something is odd. I don't know if that's serious or not. I think that's someone testing my thing. It's too much fun, right? Come on. I'd do it. Let's be honest. All right, so that concludes the Pushrod Garage, our little friend here. And I'm going to step over to the workstation for a second and check out chat and see if there's any thoughts or comments or questions on that. But I want to thank you for coming by today and let you know that I'll be working on a learning guide for that Pushrod Garage mechanism. And you can use that for a lot of different things. So we looked at last week using a slider crank, which gives you linear motion from a rotation. This, as you can see in this arrangement, gives us a opposite rotation. So we're rotating forward and down, and this one is rotating forward and up. And you can also get, oh, let's get that out of there. You can also get different angles from the input to the output. So you can see here on mine, I'll get a 90-degree angle on one and about a 60, 65 on the other. So depending on how much torque you have, you can play around with that by adjusting the length of the servo arm and the length and of the mounting arm or mounting horn that's connected to whatever it is you're moving. So that's just one example of something you can move with it. But take a look at that if you're interested, and we'll have the tutorial up tomorrow. So thank you everyone for coming out. Thanks people on Discord and YouTube, and for all of my helpers who helped with testing and using this. I wouldn't mind at all if anyone wanted to use that one more time. Oh, Dastels is using a cardboard, thinking about a cardboard breadboarding system. That's kind of cool. So, oh, we have also some advice in YouTube chat. Z-bend, you can do a modified Z-bend where the end is turned sideways to get it out easier. Oh, very cool. So I think it's like a three-dimensional Z, right? Yeah, there's some other methods of getting those on there, but Z ones seem to be easier to pull off than like these other U shapes that have clips and things. So let's see. Thank you for testing that. Whoever just tested that, I appreciate it very much, and so does Adabot. So for Adafruit Industries, I'm John Park. This has been John Park's Workshop. Thank you very much, everyone, and I'll see you next week. Bye-bye. I'll play you out.